All right, good night, everybody.
Good night.
All right, so I realized, we're going to go upstairs. I realized that we did not get a chance to do circular measures today. So I'm actually going to start this session with circular measures. With the circular measures question, they come under the trigonometry topic. And then we will drift back and try to do the surds, logs, indices, and so on. All right, so let's complete the circular measures topics first. All right, so this is the first one on 2012, this one right here. All right, so this question, but I can see the screen and hear me clearly?
Yes, sir.
Okay.
All right, good. So this question gave us this diagram, and it says it shows a sector of a circle, center O. So this is that sector, that circle, center O, and it's adjoining a square. So this is that square. And the radius is 4. This radius of the sector is 4. And so this, because this is a square, it means that here is 4, here is 4, and here also is 4. And what they want us to do, it says if the sector subtends an angle of pi by 3, which is the sector angle inside there, that pi by 3 is 60 degrees, give your answer in terms of pi, and we have to calculate the area of the shape. And it's OACMN. Right? It's the entire shape. So the area of the shape really is the area of the sector plus the area of the square. Area of the sector plus the area of the square. That's going to give us the area of the shape. All right. So let's just call that area A. And let's say that area A is equal to the area of the sector plus the area of the square. And the area of the sector is half r squared theta when the angle is in radians. And the area of that square is just 4 squared, 4 times 4, 4 squared. So this therefore is just half 4 squared. And the theta is pi by 3 plus this is 16. And the question to leave the answer in terms of pi. And so this is what? This is 16, half of 16 is 8. So it becomes 8 pi by 3 plus 16, and we're working in meters, right? We're working in meters. So we're working in meters, and that is the area. The next they want is the perimeter of the shape. These questions are very easy. The perimeter of the shape. So we're going to call that perimeter P. And the perimeter is distance around. So this piece is not included. We're going around the shape. And so it will be 4 here, 4 here, 4 here, 4 here. And then we have this arc length, which is r theta. This arc is r theta. And that's it. So it's 4 plus 4 plus 4 plus 4. And then r theta. No, this piece across is not included. Perimeter is the distance around. And so it becomes 1, 2, 3, 4 times 4. 4 times 4 plus the arc length, which is r theta. So it's 16 plus 4 times pi by 3. And so it's 16 plus 4 pi by 3. And that is meters squared. Easy question. No, not meters squared, meters. Perimeter, so it's meters. But I go to that?
Yes, sir.
All right. That finishes that question, right? Let's go to 2013. That's what was on 2013. 2013. Let's look for the circle theory on 2013, which is right here. All right. So we're looking for circle theory. And this is it right here. This is it. This is it right here. Circle theory. All right. So it gives us this sector, and it says the diagram shows a sector in the form, shows a sector cut from circle of center O. The angle at O is pi by 6. Pi by 6 is 30 degrees. It says if the perimeter is 5/6 pi plus 12 centimeters, what is the area? So they're giving us the perimeter and asking us for the area. So what it is that we know the angle and we don't know the radius. But they're telling us the perimeter. Now the perimeter is the radius plus the arc length, which is r theta. That is the perimeter. So, and they're telling us that the perimeter is equal to this. So basically, we're saying we are given that the perimeter is 5/6, 12 plus pi. But in reality, the perimeter is 2r plus r theta. That is equal to 5/6 into 12 plus pi. And this theta is pi by 6. So then this becomes 2r plus pi by 6r equals 5/6 into 12 plus pi. That's what we have. We're trying to find r from this. So what we can do, we can, multiple ways we can do it. We can multiply 2 by 6 to get rid of these fractions. And then we would get, if we multiply 2 by 6 to get rid of those fractions, we're trying to find r now, right? We would get 12r plus pi r equals 5 into 12 plus pi. And then if you factorize r from these two, because we're trying to find r, we got r into 12 plus pi equals 5 into 12 plus pi. And it works out nicely that the 12 plus pi cancels with that 12 plus pi. And so clearly the r is equal to 5. And now that we know that the r is 5 and it is in centimeters, so we can put it there. And we also have the theta, which is pi by 6. Then we can calculate the area. And that area is simply half r squared theta, which then becomes half 5 squared times pi by 6. We can leave the answer in terms of pi. It becomes 25 pi by 12. 5 squared is 25 times this pi. 2 times 6 is 12. And the unit for this area is centimeters squared. And that is it. Easy question. Easy question. Right? It's a very easy topic. But we still have to practice it. We're not taking anything for granted. Let's look at 2014 next. 2014. Looking at 2014, which is right here. So looking for the circle theory question. No, not circle theory, circular measures. So we're going this way for the circular measures. This is it right here, number 4. 4A. Is this question. This is circular measures, right? Let's see what it says. It says figure 1 shows a sector of a circle center O and radius 9. So this is a sector. This is a sector. It's AOB, OAB. So this is a sector. Right here is a sector. Just that section there is a sector. All right. And the radius is 9 and the sector angle is 0.7 radians inside here. It says find, that is all, right? Find the area of the sector. And then find the area of the shaded region, H. So they didn't tell me anything. They didn't describe anything else, but I can see the 90 degree here. I can also see this triangle. So it means that this AC is a tangent line, right? And so if I want to find the area shaded, I need to find the area of the triangle, that blue triangle, and subtract the area of that sector. I'm going to need the area of that triangle, right? So let's see what we're going to need about the triangle. To find the area of the triangle, we can use this side and use half base times height. So it means that, let me use the red ink, I need to know what this side is. And then I can use half base times height with those two sides, half the product of those two perpendicular sides. But because this is a right angle triangle, this is the angle under consideration. This is the adjacent, and this is the opposite. This is the hypotenuse side of that red triangle because it is opposite the 90 degrees, and so it's a hypotenuse side. And so I'd like to find that side. So I want the opposite, and I know the adjacent, and so I can use tan. So I'm going to find the opposite side first, over here, before I start. I know I'm going to need it to find the area of that triangle. So I'm going to start by saying the tan of 0.7, and I'm working in radians, is equal to the opposite side. And just name the opposite side AC, what it is, AC, divided by adjacent side, which is 9. So if I multiply the 9 up here, I'm going to have AC equals 9 times the tan of 0.7 radians. That's going to be AC, right? I can work out the value, or I can just leave that for now. That's the length of this side. And let me put it on the diagram. So I now know, let me clear these. I now know that this side is 9 tan of 0.7 radians. I don't have to work out the actual value, just it. All right, I just need to know what it is. All right, so we can proceed now. First part wants the area of the sector inside here. So it's a normal formula, same formula. Part 1, area of the sector is half r squared theta, because the theta is in radians. So it becomes equal to half, radius is 9, and the angle is 0.7. So that's what we need to work out. Right? Can somebody work that out for me, please?
28.35.
28 point what?
35.
So we can say 28.4 to 3 significant figures. That will be correct. Centimeters squared, that will be correct. All right, so that's the area of the sector. And then they want the area shaded. Remember, the sector is sitting in this triangle. So to get the area shaded, we have to subtract the area of the sector from the area of that triangle. So let's set it up like this for part 2. The area shaded is the area of that triangle, TRI for triangle, minus the area of the sector inside the triangle. And so the area of the triangle is half the product of these two sides. Right? So make some space and write it. So it becomes equal to half. This is the base and this is the height. I'm going to write half of 9 times 9 tan of 0.7. That gives us the area of the triangle minus the area of the sector, which is 28.4. 28.4. And then we can drop all of this in the calculator and give a one answer in centimeters squared. This will be the area of the triangle. I don't need to know the actual value, and I'm subtracting the area of the sector. But understand this work?
Yes, sir.
All right, work this one for me, please, with the calculator.
5.71.
5.71 centimeters squared. Done. That is it. All right, that is that. So let's go to 2050. Let's look at what was on 2050. 2050. Right here. All right. 2015. Looking for the circular measures. This is it. This is the circular measures. Right up here. So it says, following diagram shows a circle of radius 4 centimeters, sorry, with a center O and a sector AOB. So this is a sector AOB. And we can see a sector triangle inside there. That's a sector triangle. A triangle inside the sector is called a sector triangle. And it's subtended by an angle of pi by 6. Pi by 6 is 30 degrees. All right, at the center. If the area of the sector triangle, they're giving us the area of the sector triangle is half r squared sine theta, then the area shaded, then calculate the area shaded. So the area shaded, if you zoom it up, will be the area of the sector, the entire thing, which is the area of the sector, subtract the area of this triangle. That leaves us with this area shaded, which is a segment, which is what they want us to find, the purple segment. So it's the area of the red triangle, if the area of the red sector minus the area of the blue triangle, the sector triangle, that's going to leave us with the area shaded. The area shaded is a segment. All right, so it's a standard question, this one. So let's look at it. So it's pretty straightforward. The area of the segment, the area shaded is called a segment, is equal to the area of the sector minus the area of the sector triangle inside the sector. That is all. The area of the sector is half r squared theta. The area of the sector triangle, and they gave it to us here, they gave it to us right here. But it's not every question that they're going to tell you this. So this area of this triangle comes from the formula half AB sine theta, which is when you have a triangle AB and theta between them. I call this the trig formula for the area of a triangle from CSEC. But in this case, the A and the B are the same, R and R, and that's how we get the R squared. All right, so that's how that R squared came about. Just in case you don't know the formula, because not every exam paper is going to give you this formula. All right, so you have to know it in some exam paper. So this area of the triangle, as given, it's half r squared sine of theta. I can simplify this by factorizing the half r squared, and it will become half r squared bracket theta minus sine of theta. And it's a typical formula for a segment, if you should know. So we can substitute the values now. It becomes half, the r is 4, so I'm going to put 4 squared. The sector angle is pi by 6 minus the sine of said pi by 6. And then we can work this out with the calculator. All right, we can leave the answer in that form. This is half of 16, which is 8, into pi by 6 minus the sine of 30 degrees is a half. This is 30 degrees. Pi by 6 is 30 degrees. Sine of 30 degrees is a half. And if you want to leave it in terms of pi, 8 times this becomes 8 pi by 6, which is 4 pi by 3 when we simplify it. 8 times half is 4. So we're subtracting 4. And this would be centimeters squared. That's the exact value of it, if you want to leave it like that. Or you could put it in the calculator and work it out. All right, everybody go do that?
Yes, sir.
Yes, sir.
Good. So we see that these questions are super, super easy. Super, super easy. Let's look at 2016. See what they said in 2016 right here. Let's see if they put any sugar in any of these questions. 2016. They're very basic. They are very basic. All right, let's look at this one. This is a circle theory. Circular measure. Keep saying circle theory. Circular measures. All right. It says, diagram below not drawn to scale shows two sectors, AOB and DOC. So they are concentric sectors. They have the same center. It says OB and OC are X and X plus 2 respectively. So the radius of this smaller sector is X, and the radius of the larger sector, as you can see, is X plus 2, X plus 2. So they're giving that away in the description as well. So you have two sectors, a small sector with a radius of X and a larger sector with a radius of X plus 2. It says the angle there is 2 pi by 9. If the sector angle is 2 pi by 9, calculate the area shaded. That's quite simple. The area shaded is the area of the larger sector minus the area of that smaller sector. That leaves us with the area shaded. It's quite simple. So it's the area of the large sector minus the area of the smaller sector. Right? So we can set it up like this. Area shaded equals area of large sector, let's call it that, minus area of the smaller sector. So if you use the radius of the large sector here, so it becomes half. Radius of the large sector is X plus 2. So it becomes X plus 2 squared. X plus 2 squared, that's half R squared. The sector angle is the same for both of them. 2 pi by 9. So it's 2 pi by 9 minus the area of the small sector. The rest of the small sector is X. So it's half X squared 2 pi by 9. That's what we get. Right? And I want the answer in terms of X. Answer must have X in it. So basically that's the answer, you know, but then we can simplify it, right? So we can factorize a half and the 2 pi by 9. And so we're going to factorize a half. Well, we can work it out. The half and the 2 pi by 9, in both cases, is giving us pi by 9. So we can factorize pi by 9 into, from this one, if I were to expand this one, it will become X squared plus 4X plus 4. And from this one, I would have to subtract X squared because the half and the 2 pi by 9 are consolidated out here already and factorized. So I have X squared inside there. And then this X squared wipes out this X squared. And so we are left with pi by 9 into 4X plus 4. And you can also factorize a 4 out of here. And so it becomes 4 pi by 9 into X plus 1. And that is centimeters squared. And we won't simplify it any further. That is it. Are you okay with that?
Yes, sir.
Yes, sir.
All right, good. So it was the outer sector minus the inner sector. Done. That's it. Nothing else. You see, these questions are pretty straightforward. Let's go at 2017. 2017. 2017 is right here. All right, I think we can start working on the paper itself. 2017. This is the 2017 paper. Let's start this one. All right, let's see. So this question says, figure 1, type dog please. Figure 1 shows a plot of land ABCD. So ABCD. So we're talking about the entire thing is a plot of land, right? And it says it's not drawn to scale. It says section ABC is used for building. That's right here. is used for building. I'm going to put B right here for building, so I can remember. So this part is used for building. And the remainder is used for farming, which is right here. It's used for farming. So clearly, B is a sector, and F is a right angled triangle. You can see that. It said the radius of BC is 10. So this is 10. This also is 10, because it's a sector. It's a sector. All right? That is 10, and that also is 10. And the angle BCD is 90 degrees. Right here is 90 degrees. And then they go on to tell us that if the building space is 50 pi by 3 meters squared, that's the area of the sector right here, we are to calculate the angle ACB, which is theta. We want it in radians. So this is asking us for theta in the diagram. This angle is actually theta. So they're asking us for theta in the diagram. All right, and what they did, they gave us the area of the building as 50 pi by 3. So all we have to do is write the expression for the area of a sector and equate it to this. That's all we have to do. Because we know the radius is 10. All right, and we know that the area is 50 pi by 3. All right, that's what we know. So they're telling us that the area of the sector, area B, is the sector, is 50 pi by 3. That area is half r squared theta. That is equal to 50 pi by 3. We're trying to find what? We're trying to find the theta. All right, so we basically need to divide by the half r squared. All right, we need to divide by the half r squared. Let me shift this over and so we can have some more space to work. So they don't give a lot of space to work these questions. Right, I'm trying to find the theta. So if I were to put it here, then the theta would be, I'm going to multiply up this 2 and divide under the r squared. And tell me if it's what I'm going to get. When I multiply up the 2, I'm going to get 100 pi divided by 3 times r squared. And r squared becomes 10 squared. But you can see that?
Yes, sir.
Yes, sir.
And so this becomes pi by 3. And pi by 3, remember, is 60 degrees. So always be thinking of what the actual angle is in degrees. It's 60 degrees. So this angle right here is 60 degrees. And if right here is 90, it means that the angle inside here, this one, is 30 degrees, which is pi by 6. It's 30 degrees, which is pi by 6. So this angle is 30 degrees, which is actually pi by 6 in radians. That angle right there. That's because this angle is 60 degrees, because this is actually 60 degrees. All right? So that's where I found the angle. 1 mark for that. All right? So now we know the angle inside the sector angle. Next thing they say, working in radians, calculate the area used for farming. So we want to calculate the area of F now. Remember that because this is a sector, that's the radius. This is 10. So it means that right here is also 10. This length is also 10 meters. All right? To find the area of that triangle, it will be good if we can find this side and this side. Now we could do half base, half this base times this height. But we don't need to use that formula. We can actually just find this side only and use these 2 sides and the angle between and say it is half AB sine theta. Well, not theta, but the 30 degrees. Half AB sine 30 degrees. That will give us the area inside here. And I'm going to call this A, I'm going to call this side B. So we need to find this side. We need to find that side, the DC. Now, if we're going to use this formula, right? We need to find that side. So what is that side equal to? It's a right angle triangle. So we could use cos equals adjacent over hypotenuse. So if I were to show the work right here, let me shift this up. in a different color. To calculate this side, we could say cos of the 30 degrees, because adjacent, it is DC, over the hypotenuse is 10. Multiply by 10, so DC becomes 10 cos 30 degrees. Now cos 30 degrees is root 3 over 2. So this becomes 10 times root 3 over 2, which then is 5 root 3. 5 root 3 centimeters. Hello? Everybody's there still?
Yes, sir. Yes, sir. That's
Yes,
good.
sir.
Okay. So that side is now 5 root 3. And so the area is for farming. If we were to calculate it down here, the area is for farming, let's call it area F, to be equal to using the same formula, half AB sine of 30 degrees. You know the angle is 30. I'm not going to call it theta because this is theta. Then it would be half, the A side is 10, the B side is 5 root 3, and the sine of 30 is a half. Sine of 30 is a half. And that will give us the area used for farming. This becomes 5 times 5, that's 25 over 2 root 3. So we get 25 root 3 over 5 over 2. 25 root 3 over 2. And that is meters squared, working in meters. I add centimeters here, it should be meters right here. This should be meters right here. Meters. So this is it, meters squared. That is it. Half of the 10 is 5. 5, 5, 25, and then I have this half again. So that's it. So it's 25 root 3 or 2 meters squared. That's the answer. But okay with that? But okay?
Yes, sir.
Yes, sir.
All right, good. Let's go to 2018. 2018. 2018. So 2018 is right here. All right. So looking for the circle question. I think this is it. This is it. All right, so let me expand that since we're gonna work on the sheet. All right. So this question says, a wire in the form of a circle of radius 4 centimeters is reshaped in the form of a sector of a circle of radius 10. Determine in radians the angle of the sector, giving your answer in terms of pi. So let's do a sketch of what they have said. So what they have said is that we have a circle. And in this circle, the radius is 4. That circle is transformed or reshaped into a sector where the radius is now 10 centimeters. 10 centimeters. So it is a piece of wire, you know, guys. And the piece of wire was reshaped from this to this. So the length of the wire is the same. So it means that the circumference of a circle is now equal to the perimeter of the sector. This arc length up here is r theta. If we call the angle theta, r is 10. And so it is actually equal to 10 theta. One knows that the perimeter of the sector is equal to the circumference of the circle. That's how we're going to solve this question. The perimeter of the sector is equal to the circumference of the circle. Or we can say the perimeter of the circle, same difference. Because it was the same length of wire that was used. Now the perimeter of the sector is 10 plus 10 plus 10 theta. And you can leave these diagrams on your sheet, on the paper, to see how, because see if you can see how you get your values. So it's 10 plus 10 plus 10 theta, trying to find the sector angle theta. That is equal to the perimeter of the circle, which is the circumference, which is 2 pi times the radius, 2 pi times 4. 2 pi r is the circumference. So solving this for theta. To simplify this, it is 20 plus 10 theta equals 8 pi. We need to divide, subtract the 20 and divide by the 10. So theta is going to be 8 pi minus 20 divided by 10. And the question to leave it in terms of pi, but this can be divided through by 5, by 2. By 2 by 2, we get 4 pi minus 10 over 5. And that is in radians. And that is our answer in terms of pi. I mean, pi is in the answer. That's it. Easy question. The length of wire remains the same. So the circumference of the circle that was there before is now equal to the perimeter of the sector, which is the 2 radii plus the arc. Radius plus radius plus the arc. And that is it. Excuse me with the dog, please. Excuse me with the dog, please, please. All right? Better go with that?
Yes, sir.
Yes, sir.
Right, let me see if we can do the dog. Just give me a second. Just give me a second. All right, guys, sorry about that. All right, let's continue. So that finishes that question. But okay with that?
Yes, sir.
Okay?
Yes, sir.
All right, good. Let's go to 2019. 2019. So rolling through this very quickly. That's a really very easy topic. 2019 is right here. All right, 2019. Right, this is the question for 2019. All right, so the question says, compass is used to draw a sector of radius 6 centimeters and the area of it is 11.32 centimeters squared. Determine the angle of the sector. So what they're telling us is that we have a sector, radius is 6 centimeters, and the area is 11.32 centimeters squared, and we want to find that angle. So they're basically telling us that half r squared theta is equal to 11.32. That's what it is, because this is the expression for the area. That is it basically. We're trying to find this theta. So again, we can multiply it by the 2 and then divide on the r squared. And so the theta will become 2 times 11.32 divided by the r squared under here, and the r is 6. So I'm going to put 6 squared under here, and then work that out. I will leave it in radians. Can somebody work that out for me, please?
.629.
Come again.
0.629.
0.269. I don't hear it clearly.
629.
0.629.
Oh, but 0.629. 0.629. 6.29 radians. Okay, that is the sector angle. And then they want the perimeter of the sector. So all we need now to get the perimeter is the arc length. But we know the two-way there already. And the arc length up here is simply equal to r theta. That's it. So the perimeter is equal to 6 plus 6 plus r theta. R is 6. So it's 6 plus 6 plus 6 times 0.629. That gives us the perimeter. Nice and easy. Right? So we can write that one out as well. What's the answer there?
Fifteen point 15.8.
15.68.
7.
15.7. The three significant figures, and it is in centimeters. Done. Anything else? Nope. That is it. So see, these questions are really very easy. 2021 next. 2021 next. Let's go. 2021. Right here. 2021. Before. I'm not seeing a circle question here. That is none in 2021. Looks like there was none on 2021. 2021. So this is differentiation. All right. So it looks like there's none on 2021. All right. Let's go to 2022. 2022. Let's see what happens. There's so many topics. I cannot set everything everywhere. So 2022 is right here. That's a circle. Circle measures question 2022. This is it. And this one says, the diagram below, not drawn to scale, shows a chord AB, that's a chord AB, which subtends an angle of 0.5 radians. So the sector angle there is 0.5 radians right here. 0.5 radians, 0.5 radians, same thing, 0.5 radians. At the center of the circle, and the radius is 10. So the radius is 10. Given that the area of the triangle is half r squared, so it's basically a repeat question. Calculate the area shaded, so it's a repeat question. The area shaded is a segment, so it's the area of the sector again, minus the area of this triangle gives us the area shaded, which is a segment. So the area of the segment, the shaded segment, is equal to the area of the sector minus the area of the sector triangle. The area of the sector is half r squared theta minus the area of the sector triangle is half r squared sine theta. Remember, this formula comes from the formula half AD sine C. Just like the A and the B each equal R. So it becomes R squared. Right? And we can factorize the R squared, the half R squared. So we get half R squared into theta minus sine theta. That's what it becomes. Let me just make this a little smaller and then run the numbers. All right, so let's make that a little smaller and then we can put in the numbers. So it becomes half, if the radius is 10, so it becomes half 10 squared bracket. The theta is 0.5 radians, so it becomes 0.5 minus the sine of 0.5 radians. Put that in the calculator and tell me what it is. Let's shift it over. How this work out to this line? Let's put that in the calculator. The half of the 100 is 50. What did you get? Anybody?
11.99.
11.9
Yes.
centimeters squared. It's in centimeters, and that's it. That's it. All right. We're going to jump over to the specimen paper. Specimen paper. Specimen paper is right here. We just did 2022, right? Just did 2022, right? So we're doing the specimen paper now. Let's see. We didn't do this question today. Wait another page. We want to the magnitude of dp. This is easy. It's part of it. This is dp. Then the magnitude of dp would have been the square root of 1 squared plus 7 squared. That's 49 and 1 make 50. It will be the square root of 50. But I said I want it in simple form. So this can be written as the square root of 25 times 2. Square root of 25 is 5. So it will be 5 root 2. 5 root 2 units. Just hit out that question earlier today. But anyway, let's look for the circle question. If there's any. Apparently there's none. So you see, they're not able to set it on every paper. So there's none in the specimen paper here. That is it. All right. So the topic I'm going to look at next is either logs or inequalities. Logs or inequalities. All right. Let's do the logs. Give me 1 second. Give me a second. Just give me 1 second, please. All right, guys. So let's go. So let's do the logs questions, and then we're going to go back through and do the inequality questions. All right? Let's do the logs questions right now. So this is a logs question. Right here. Now to do the logs questions, you have to know the laws of logs. You have to know the laws of logs. As simple as that. Let me write out some of them over here. You have to know the laws of logs from both directions, not just left to right. You have to know them from right to left as well. Right? You have to know the laws of logs when the base is the same. Your laws of logs is when the base is the same. The first one is that the log to a base of a product AB is equal to, or they usually use M and N, no matter, M and N is equal to the log to the same base of M plus the log to the same base of N. You have to know the law from left to right. You have to also know the law from right to left. So if you have this situation, you have to be able to write that one. And if you have this situation, you have to be able to write that one. You have to know the laws from left to right. That's the log of a product. Then the log, the base of a quotient, M over N. We take the difference, it becomes the log to base B of M minus log to base B of N. That's when they're the same base. You have to know the law from this way. You have to know the law this way. All right? Then the third law that you must know, I call it the power law, which is to say the log to base b of a number raised to a power, and let's say raised to, I don't want to use p for power, I'm going to show you something else with a p. Let's say it's raised to a power n then, n. This n can go to the front. And so this will become n times the log to base b of m. So given this one, you should know that the n can go on there and become the power. Given this one, you should know that the n can come to the front as a multiple. You have to know the law from left to right. You have to know the law from right to left. Then now I come to what is the relationship between, there are a couple of other things that you must know. That the log of a number to the same base is equal to 1. And that the log of 1 to any base is equal to 0. The log of 1 to any base is equal to 0. Now, what is the basic theory of logs? The foundation of logs. All right, what is the relationship between logs and indices? And this is it. The log of a number to a base is actually equal to a power. What power? It is equal to the power to which the base must be raised to this power, p. This base has to be raised to this power p to be equal to this number. So this number is equal to the base raised to the power p. So it is equal to the base raised to the power p. This is a relationship between logs and indices. You have to be able to go from this one to this and vice versa. So this implies this, and this implies that. You have to be able to go both ways. All right? Another thing I want to show you before we go. Two things I want to show you. If I have a number, for example, 3, and I want to write this as a log to base 2. If I want to write 3 and convert it to logs to base 2, all I need to do is multiply it by log to base 2 of 2. Because remember, log to base 2 of 2 is 1, and then I can move this 3 up on the power. Right? And so it is the same as log to base 2 of 2 cubed. That's what the original 3 is equal to now. Right? So as simple as that. Let's go again. If I have a number in an equation and I want to convert it into a logged expression, I just need to multiply it with a different color. I just need to multiply this 3 in my expression by log to base 2 of 2. If I'm working in base 5, then I need to multiply by log to base 5 of 5. Any base I'm working in, because this is equal to 1. And then the power can go up there, and the multiple can go up there. And so the 3 would have become log to base 5 of 5 cubed. And 5 cubed will be 125. So it would have become log to base 5 of 125. This 3 that I had would have become that if I want to write it in terms of logs. Simple as that. All right. One last thing I want to show you. When you're solving logs equations, your aim is to do one of two things. Your aim when solving logs equation, like for example, this one over here, your aim is to do one of two things. The first thing you want to do, depending on what you have, you want to reduce your equation such that it becomes an equation of the form log to a base of a number on this side equal log to the same base of a number, a different number on that side. Then this would imply that the n equals m. N would be equal to m, and then you would solve this. Then you would solve this. From here, you would solve and get the answer. The other thing that you might want to do when you're solving a logs equation. You want to reduce your logs equation to this. Log to a base of a number equals a power. You want to reduce your equation to look something like that. And then this would imply that the number is equal to the base raised to that power. The number is equal to the base raised to that power. Then you would solve this. You would solve this. So every time you have a logs equation to solve, your aim is to bring it simplified down to look something like this, which then would imply that, or you bring it to look something like this, which then would imply that. And then you solve. And that is how you solve logs equations. Right? So let's see on this one over here now. Let's go. All right, let's see. Let's see on this one. So this gives me this equation. And everything is in base 2. Everything is base 2. Let's zoom it up. This is base 2. This is base 2. And the question says, if this is equal to this, what is the value of A? They're asking me to find the value of A. To find the value of A, I need to simplify it down. First thing I notice is that this is log to base 5 of 5. It must equal 1. Not complicated. That is equal to 1. Log to base 5 of 5 is equal to 1. Log of a number to its own base is equal to 1. Another thing you want to know is that when you're doing logs question, you don't want to be working in multiple bases. This is base 2. This is base 2, but this is base 5. But they gave you the log to base 5 of 5. So you're testing your knowledge if you know that this is equal to 1. Right? You have to know those things. Log of a number to its own base is equal to 1. That's what I gave you right here. Log of a number to the same base is equal to 1. All right? Then, oh, by the way, you can't find the log of 0. The log of 0 to any base does not exist. And the log to a base of a negative number. So if the n is less than 0, then this does not exist. It does not exist. And this does not exist either. Does not exist. So these do not exist. The log of 0 don't exist, and the log of negative number does not exist. So when you write the log of base of a number, that number has to be, the number has to be greater than 0. The number has to be greater than 0. So if you solve a logs equation and you get a value that is causing this to be negative, you cannot accept it. Because the n in the logs cannot be 0 and it cannot be negative. The n has to be greater than 0. You can only find the log of a positive number. You can only find the log of a positive number. That is assuming that the base is positive. All right, let's continue. Right, so I'm solving this equation. As I said, when you're solving a logs equation, which is what this is, you want to simplify it down to one of these two things, either to this or to this. Now, because firstly, I recognize that that is 1. This is a subtraction. So I'm subtracting this log minus this log. So I'm going to use the second law, the subtraction law. So it becomes the log of the quotient. So this whole thing becomes the log of the quotient. So the left side becomes the log to base 2 of this divided by that, which is 4 minus root 8 divided by 2 minus root A. And that is equal to 1. Equal to 1. That is equal to 1. Right? Now, if that is equal to 1, it means that this number is equal to this base. How do I know that? Remember, the log of a number to its own base is equal to 1. That's what it said here. Log of a number to its own base is equal to 1. So the log of a number to a base equal 1. It means that them two numbers here, the base and the number must be the same. Right? Right? So this must equal 2. But if you don't know that, you can recognize that we have actually gotten to the stage where this now is this form that we have here. And so what it means is that this number is equal to 2 raised to the power 1. So I can write that. 4 minus root 8 over 2 minus root a is equal to this base raised to this power 1. Remember, this is the number, this is the base, this is your power. Number, base, power. Number, base, power. So it is the base of 2 raised to the power 1, but 2 to the 1 is still 2. And so I'm now solving this. So I can just cross multiply this over here, and I will get 4 minus the square root of 8 equals 2 times these, which would give me 4 minus 2 root a. What you realize now is that this 4 cancels this 4, the minus cancels the minus, and so we're left. Look at it. This thing equals that thing, obviously. So what we have gotten to is that root 8 is equal to 2 root a. That's what we have gotten to. Root 8 is equal to 2 root a. All right? And to simplify this now, I want to get rid of that square. So I can square both sides. So we can square both sides, square this side, and square this side. That's one way to do it. Or we can use indices and simplify the surds and simplify the surds and write this 4, this 8 as 4 times 2. And I will square it over it, and I will square root of the 4 and bring it out of that 2. That's another way we could do it. And so we do it that way. Let's do it that way. Then we would have this becoming the square root of 4 times 2 equals 2 times the square root of 8. And then the square root of the 4 is 2. So it becomes 2 times the square root of 2 equals 2 times the square root of 8. So the 2's cancel, and clearly then the a equals 2 inside here. The answer is that a equals 2. That's my answer. And that's not the only way to do it. That's the beauty about logs question, not one way to do it. Because you have all those logs and tricks. I like logs and tricks for the reason that you can usually do them multiple ways, not one way to do them. But okay with that?
Yes, sir.
So remember, solving these questions is centered around your knowledge of the laws of logs. All right, let's go. Let's run through them now. All right. So let's do 2022. 2022. I'm going to work through the logs question now. So 2022. We're in the 2021, you know. Oh, there was no question in 2021. So 2022. Looking for the logs question in 2022, which is somewhere at the top. 2022. It's normally in question 2. 2022. Well, this is surge. Do we do surge, logs, and indices same time? I think we should do surge, logs, and indices same time. You know? Surge, logs, and indices, they're all related. So one of the surge, logs, and indices same time. So this is a surge. I don't think there's a logs there. Right? Let me see. So the question done, because it's either a surge, logs, or indices you're gonna get. So we're gonna do those 3 things one time. So looking at the papers, we're looking for surge, logs, or indices. So not seeing any logs, but we have indices on the paper, right? Which is right here. This is it. Indices right here. This is it. All right? So this one is about simplifying. And I said, show that this expression is the same as this. So you can just drop it in the calculator and work it and give the answer, guys. Right? You have to simplify these values, simplify them down. So I have the square root of 25 over the square root of 45. And what it is that you're normally looking for perfect square. Now, we know the square root of 25 is 5. But this 45, The perfect square number, the square factor in this 45 is 9. So I'm going to write this as this becomes a 5. And under here, I'm going to write this as the square root of 9 times 5. That's what I'm going to write it as, 9 times 5. Then the square root of the 9 is 3. So it becomes equal to 5 over 3 times the square root of 5. Well, that's not what they have. So to get the square root of 5 up here, I need to rationalize this denominator, rationalize that root 5. To rationalize the root 5, I have to multiply it by the same root 5. And then multiply by the numerator by root 5. That's what I'm doing to this. Multiply it by root 5 over root 5. What will I get? This becomes equal to the root 5 times root 5 is 5. So the numerator becomes 5 times root 5 divided by the denominator becomes 3 times 5. Then this 5 cancels this 5. And so I'm left with 5 root 5 over 3. And so shown. And it's not the only way to do it. I always like to say this is not the only way to do it. So this is a good enough way to do it. Right? But that's not the only way to do it. But I write that. But okay?
Yes, sir.
Yes, sir.
All right. That's not the only way to do it. If I do it again, I might do it a different way. All right? I might do it a different way. If I do it again. All right? Let's do it one a different way. Let's just show you something. So I have root 25 over root 45. Watch me now. I realize that the denominator of my answer is already rationalized. Right? It's already a rational number. There's no root anything under here. So I don't want this root 45 under here. So I can simply proceed by multiplying this by the same root 45 over root 45 to rationalize my denominator. If I do that, then this already is going to give me 5. So I'm going to get 5. The root 45 up here is the same, still 9 times 5 divided by this under here. Root 45 times root 45 gives me 45. 45. That's the first step. Then I'm going to break away this 9. Root of 9 is 3. And the 3 times the 5 is going to give me 15. So I'm going to end up with 15 root 5 over 45. Then 15 goes into 45 3 times. So it then will become root 5 over 3, which is the same thing. See that? So I just did it this other way to show you that it's not one way to do it. Okay? You understand that?
Yes, sir.
Yes, sir.
All right, good. So let's go to 2021. We're looking for SIRS, logs, indices. We're doing all of that as one topic. Because they usually set one or the other. SIRS, logs, or indices. They don't usually set all of them. All right? Let's look at 2021. SIRS, logs, and indices is like one topic. We're looking for 2021 now. 2021 paper. 2021, where is it? It's all the way down here somewhere. 2021, right here. I think we'll skip over this paper under the circle here. We didn't see it. Circular measures. There's no circular measures on this. I feel as if we skip over this paper. No. Anyway, all right. So let's go up here. All right. So this is a logs question right here. This is actually a search question, a logs question. This one. This question is actually an indices question. This one. So we can maybe look at that one as well. So let's go. So this is a logs question. And this is almost the same as the one that we did before. See, asking us for A again. But this time I give us a log of 10. Now, when I say log without any base, it means log to base 10. Log without any base shown means log to base 10. So this is almost the same question that we did before. So this is equal to 1. So because the same question, a while ago they gave us log to base 5 of 5 there. Now they're giving us log to base 10 of 10. Or LOG means log to base 10, just that they're not going to show the 10 minutes base 10. It's understood. So that is equal to 1. And this again is a minus, and so we're taking the quotient. So get another chance to do the same question. And that's the beauty about AdMaths. They keep repeating the questions. That's why you're not supposed to fail it. So this expression, this is a subtract. It's a subtract, so we're taking the quotient. It becomes log to base 2 of this divided by that. So it's 6 plus root 12 divided by 3 plus root a. And that again is equal to 1. And I just said it. If the log of a number to a base is equal to 1, then it means that the number and the base equal. So I can put these two equal. Or I can go back to the law of logs and say, this is my number, this is my base, this is my power. You know how it go? Log of a number to a base is equal to a power. The number is equal to the base raised to that power. So this number is equal to the 2 raised to the power 1 over here. Log of a number is a power. This is always a power. This is always a number. This is always a base. All right? So if we're using that, then this raised to the power, base raised to the power. Then the number here, which is 6 plus root 12 divided by 3 plus root a, becomes equal to 2 to the power 1, which is 2. It's the same calculation again. I'm going to multiply this across here by the 2 first. So I'm going to get 6 plus root 12 equals 6 plus 2 root a. This 6 cancels this 6. And so I'm left with root 12 equals 2 root a. So root 12 is equal to 2 root a. Now, when we did it a while ago, we'll break this 12 down into 4 times 3. And then it became 2 root 3 equals 2 root a. And so the a and the 3 equal. I'm going to use a different method this time from here. Just to show that there's no rote in this thing. There's no rote learning in it. You just work with what is in front of you or it comes to your mind. So another way to solve from here is to move the square root signs by squaring both sides. And you square the full side. Remember the answer is 3 now, a equals 3 now. I'm going to square both sides. When I square both sides, this becomes 12 for the blue. This becomes 12. This becomes 4. When I square the 2, I get 4. When I square the root a, I get a. So if I divide both sides by 4 now, I see that the a equals 3. So you see that the a equals 3 using another method. A equals 3. This is my answer. So from that line, we have used a different approach. But go to that.
Yes, sir.
All right. All right. So let's continue. I'm going to do this question because this question really is a, it says a GP, but it's not really a GP. You know, it's more a logs question. A logs and indices question. I'm going to show you something now with this. Let's do this one. We're not going to do it like a GP. We're going to do it like an indices question, right? This one. So it says Alice deposited $4,000 into her new savings account at Bank of Fortune, which pays interest of 8% per annum. All right, 8% per annum. The bank's compound interest is represented by the geometric progression. And this is that geometric progression where A is the amount accumulated. So this is the amount accumulated. That is inclusive of the principal and the interest. All right, because it's growing at 8%. What it means is that this R is that 8 right there. This P is the principal amount of 4,000 right there. This T is the time in years. See that? The T is the time in years. And they told us here, A is the amount accumulated after t years. R is the rate percent increase per annum. So R is the same 8 up there. 100 under here is taking care of the percentage aspect of it. So the R really is just equal to 8. All right. And the R is positive, the T is positive, right? They are positive integers. That's what they're basically saying. The R, rate of interest, and T, a positive integer, the time in years. So T is the time in years. Determine the number of years it would take for Alice money to at least triple. At least triple. The time it will take for her money to at least triple. But when her money triple, it means that the amount accumulated is now 3 times the principal amount. That's what it means. When our money triples, the amount accumulated, when the money triples, right? The amount accumulated, the A, becomes 3 times the principal. That's what I mean by our money triples. So this becomes 12,000 or more. All right? So we're gonna find the time when it triples, which is basically solving this equation. So the A here becomes 3p. So this equation becomes 3p becomes the A, 3 times the principal, equals the principal times, and you see what we're trying to find here is a t, determine the number of years. So we're trying to find a t. This means that we're trying to find a time. Determine the number of years, meaning that we're trying to find a time. That's what we're trying to find. So we're trying to find a time that is up here. So let's go back to this. It becomes equal to 1 plus 8 divided by 100 to the power t. We're solving for that t. So it becomes an indices question. Right off the bat, because of these numbers, the p cancels the p right here. So it becomes 3 equals, and this inside here becomes 1.8, 1.08. So it becomes 1.08 to the power t. But understand that? But understand that?
Yes, sir.
Yes, sir.
Right, but the p's cancel out on both sides. So this side becomes just 3 when you divide out the p, and this p is gone, and this inside here becomes 1.08 to the power t. Now listen to me now. When the thing that you want to find is in the power, you have to take logs to get it out of the power. When the quantity or the variable you want to find is in the power, to get it out of the power, you take logs, because you want to be able to use this law. You want to be able to use the power law that says the log of a number that is raised to a power n, or the log of x, let's use x. The log of x raised to the power y, the y can come to the front. That's how you get it out. Right? So if you take the log of this, the y can come to the front. So this can be written as y log of x. That's what we're trying to use. This becomes that. Right? So we have to learn these laws. Let me change this color to red. Hold on. Change this color to red. Right, so you have to be able to, you have to know these laws. And that's why we take logs when the thing that we want to find is in the power. So it means that I'm going to take logs of both sides. Let me shift this over and show you. I'm going to take logs of both sides. All right? So I'm going to take the logs of both sides. I'm not going to work log to base 10. Add masses of log to base 10. So I'm going to log the 3 and log this side as well. So I'm taking the log of both sides. So the log of 3 becomes equal to the log of that. Then this t can come to the front, right? Using this law. So I end up having that the log of 3 is equal to t times the log of 1.08. Got the t gone to the front and is now right here. So to find the t, we just need to divide the log of 1.8 under here, 1.08. So the t is equal to the log of 3 divided by the log of 1.08. Let's work this out with the calculator now and get the t. T equals what? Work that out with the calculator. And what the number of years?
14.3.
14.3?
Yes, sir.
14.3, so you have to put 15. So t number of years is 15 years. That's 15 years. Remember the question said there are integers, positive integers. See? R and T are positive integers. So can I have no point now? Number of years. So if you get 14, you can't, if you get 14.3, you can't go back to 14 now. If you go back to 14, you're going less than the time for it to triple. So the number of years is 15 years. It takes 15 years. The question said you have to be integer. So it's 15 years. You have to go forward. So this is my answer. 15 years it takes for it to triple, at least triple. But I go to that.
Yes, sir.
You can't go back to 14. If you go back to 14, the money will not have tripled as yet. You have to go past 14 years for it to triple. So you have to at least 15 years. That is the point. Very good. Very good.
Yes, sir.
Yes, sir.
All right. So that finishes that question. Take care of the dog for me now and make Kaiko. She in the room and try to keep the dog quiet because you're erratic. No, he's making that all the time. That's why I shop there with him. Just hurry up and go take him because she's not able to pay attention. Sorry about that, guys. All right, so that's 2021. And that finishes that question. Let's move on to 2020, 2019. There was no exam in 2020. So 2019. 2019. All right. So let's go. So looking for the search logs or indices, usually in question 1 or question 2. We just would not behave. All right, here's a logs question. Let's see if there's anything else. This is a functions, and function is no longer on the syllabus, right? So we're not gonna do that one. So we're only doing this one right here. We want to solve this. We want to solve this. Remember, when you're solving, you're trying to get log of a number to a base equals a power, which would imply that the number is equal to the base raised to the power, and then you solve. Or you're trying to get the log of a number to a base equal the log to base of a different number, and then this would imply that the n equals the m, and then you would solve. When you solve when it's doing an equation, a logs equation, you're trying to get this situation, or you're trying to get this situation. Now, based on the fact that I have a number over here, it's clear that I'm trying to get the first situation, this one, with the number over there. So I'm going to consolidate the log terms on this side, right? That's what I'm going to do. So I'm aiming for the first situation. No. To do that, remember, I have to move this power and put it up here. That's what I have to do. Don't have to, now. There are many ways to do it because I can break this 8 as well and put it as 2 right? But I'm going to use the approach where I move this 3 and put it up here, the 3 squared. So I end up getting log of 2 to the 3 to the 3x, because the power come up here, plus the log of 8 to the x equals 2. And these are some indices in the as well. You see this power of 3x, 2 to the 3x, it means that I can break it like that. The 2 cube. That's a law of indices. All right? Let me show you that law. The laws of indices that you have to know. We're doing logs and indices. So what are the laws of indices? A number to a power multiplied by same base to another power, you can add the powers, e plus q. Number to a power divided divided by a number, same number, for different power. You can subtract the powers, e minus q. Then you have the power one, which is a number raised to a power, raised to a higher power. You can multiply the powers and put p times q. Power becomes p times q, p times q. So this one is what I just applied. I just applied the last one down here. Remember, I know you have to know the laws from left to right and from right to left. You have to know the laws both ways. These are the three indices laws that you must know. So what it is like I have this one and I'm breaking it here. Right? So this is my 3x. If I remove these again, I have my 3x as a product power. So I can break it and raise the 2 cube to a higher power of x, because it's still equal to 3x. And this inside becomes 8. So this expression becomes the log of 8 to the power x plus the log of 8 to the power x equals 2. And so we have two of the same things. Two of the same things. So we get 2 times the log of 8 to the power x equals 2. And we can divide both sides by 2 and get the log of 8 to the power x equals 1. Remember, when you don't see any log on it, it means you're working in base 10. We're working in base 10. When they don't show you any base, say log and log, it means that you're working in base 10. I just don't write out LOG, I write LG. Right? It means the log is just the same. But I'm working in base 10. This is base 10. When they're not sure, when they don't show it, it is base 10. So using the laws of logs now again, I can move back this x to the front. And so I'm gonna get move what you want from out the 4. Move what you want from out the 4. And so you're gonna get x log of 8 equals 1. And I can divide by the log of 8. And so the x equals 1 divided by the log of 8. You can leave us as the answer, you know, because that is x, or you can work it out. So that is it. You're gonna work it out, you're gonna put log of 10, log of 8 on your calculator. So that is it. So the x equals 1 over the log of 8. Using the laws of logs. And again, this is not the only way to do it. We've done this 10 different ways. But okay with that?
Yes, sir.
Yes, sir.
All right, good. All right. Let's continue. Let's continue. I'm just kind of tempted to show you another way that you could do it quickly as well. Now, watch this now. Trying to find x, right? Let me show you a way you could do it quickly. Right? Let me show you a way you could do it quickly. Watch this now. Let me show you another way you could do it, which would be acceptable just the same. Let me show you a way you could do it. We're really just trying to find x, right? Practically trying to find x. So, and you can test the answers and see. I'm trying to find x out of this equation, right? So I have 3x log 2 plus log of 8 to the x equals 2. I'm going to take this x out of the power right now. And I'm going to get 3x log of 2 plus x log of 8 equals 2. By x I'm trying to find, and so I can factorize away the x from these two terms. If I factorize away the x that I'm trying to find, I'm going to get x bracket 3 log 2 plus log 8 equals 2. And in simple terms, I can divide all of this under the 2 and leave x as a subject. So x would be equal to 2 divided by 3 log 2 plus log of 8. That is correct as well, isn't it? That is also correct. And if you leave that on the paper, CSEC have to give you your marks. It's still correct. You have made X a subject. If you want, you can put this in the calculator and see what you get. X equals, put it in the calculator. I'm going to say we're going to the same answer as this one. Put them in the calculator for me. Put this in the calculator and put this in the calculator. I'm going to see that we get the same answer for both of them. Put them in the calculator for me.
Yes, sir.
1 point.
1 point what?
107.
Come again?
107.
1.107. Let's give it the same thing, don't it? See that? But I think CSEC want to leave your answer in exact form like this and like that. You don't want to give values where you have to round off. You want to leave your answers in exact form, right? Because they didn't tell us how accurate they want the answer. But I think if you solve it down to this and give them that, or give them this, they'll have to give you a mark. So again, we could have solved it that way as well. Just go straight at making X a subject right there. Right? Without troubling ourselves too much with the gymnastics with the laws. All right, so that finishes 2019. Let's look at, let's make sure there's no other one for us to do. Question 1 and question 2. Let's make sure. We're doing surds, logs, and indices. All right, let's finish this. All right. Let's jump to 20. So we're going backwards. I'm going forwards. Let's see. Which one is supposed to do next? Which one is supposed to do next? Huh? 2018? 2018 next? Or 2021?
So 2021.
Oh, okay, 2021. All right. 2021, let's look up here. If there's anything. Question 1. No surds, logs, and indices there.
So we did 2021 already.
We did this already?
Yes,
Yeah,
sir. We
yes,
start.
sir.
We start 2022.
Oh, we
So
went down. We were supposed to go 2018 then.
Yes, sir.
Yes.
All right, 2018. We're going backwards. 2018. All right, cool. 2018. All right. Let's go. 2018. Right. This one is this is actually logs, you know. This is actually logs, and it has some linear reduction in it. So might as well, right? Might as well. It's actually logs, and logs linear reduction comes under the logs topic on the syllabus. So this says an equation relates V and T. This is an equation relating V and T, and K and the A are constants. So V is a variable, T is a variable, just like a Y and a X. They're variables, right? And the A and the K are your constants. It says use logs to derive the equation in the form y equals mx plus c that can be used to find the values of K and A. So they want us to take this equation, take logs, get the T from out the power, and rearrange it in a form like this. Now, when you rearrange it in a form like this, what is supposed to happen is that the Y is going to be some function of the V and or the T, and the X here is going to be some function of the V and the T. And then this constant will comprise of the A and the K and the A, which are constant, and this constant C again consists of the A and the C. All right? So the first thing you want to do is get it in a linear form by taking logs of both sides. All right, so let's go now. So we have the V equals Ka to the power T. We're going to take logs of both sides because we want to get this T from out the power. All right? We want to be able to multiply constant by, so we need to get that variable t from out the power. So I'm going to take logs of both sides, log this side and log this side. Then we have to see this as the log of a product of two things, log of a product. And so if we expand this part out using the law of logs, first one, this becomes the log of v just same, and this becomes the log of k plus the log of a to the power t. But understand that, because I'm treating this like a product, this and this. The log of a product is equal to this, sum of the logs. And then this t comes to the front. All right? That t comes to the front, and so it becomes the log of v equals the log of k plus t times the log of a. Remember now, my variables are these. This is a variable, and this is a variable. So it means that this is a constant and this is a constant. And I'm trying to get them in the form y equals mx plus c. So if you look at it, this is like the y. I'm going to leave that. It's a log of v. It's like the y equals. This is like the m. And this is like the x, because that's a variable. So I'm going to write back this and put it first, because I'm trying to mirror the mx. And so I'm going to write it as the log of a times t. So this is my m plus the log of k. So now it is in the form, and write it out, y equals mx plus c. So all of this would be my y, this would be my x, this would be my m, my gradient, this would be my c. So based on that, if I draw a graph log y against t, it's going to produce a straight line where this becomes my gradient as it is here, my m. And this is my y-axis intercept. But understand that?
Yes, sir.
And the question
Yes,
is
sir.
asking you here, if a graph of y versus x, if you recognize that, you're really talking as if this is our y. So we're talking about log v against x and talking about t. So in other words, if you plot a graph of log v against t, that's what I really mean here now. But y is log v, so it's log v versus log v versus x. We're talking about the t. The plot a graph of log v versus t, you're gonna get a straight line because this is in the format of a straight line. So you plot this against this, and this is going to be a gradient, and this is going to be a vertical axis intercept. They're asking us, when we get that straight line, what is going to be our gradient? So they're asking us here, what is going to be the gradient? The gradient is going to be the log of a. So the gradient is going to be the m, which in this case is the log of a. If they wanted the log v axis intercept or the y axis intercept, then to be the c, which is the k, log of k. So we can add that and say something like the log v intercept. Well, log v is the y axis now. Log v intercept would be the c, which is equal to the log of k. So this would be the log v intercept, and this is the gradient. But understand that? So the answer for this question is log of a now, right here. Log of a is the answer for this one. Log of a. Are you good with that?
Yes,
Yes,
sir.
sir.
All right. So that is reduction of a equation to a linear form. Call it linear reduction. right? And that comes under the logs part of the syllabus. So that finishes that on 2018. That's the extent of it on 2018. All right, so we'll finish and we'll see all these papers full up in every question, right? Want to finish all the questions. So we have these in module we're here to do tomorrow, differentiation and integration and so on, right? All right, let's go to 2017. 2017. There are some interesting questions about to actually draw the graphs and stuff in the linear reduction, right? And actually calculate some values. 2017, right here. All right, so we're looking for surds, logs, and indices. Usually question 1 and 2. Just inequality. Don't know if we can try the inequality tonight as well. Let's try if we can speed up. So here's one where you have to draw the graph. This is one in you have to draw the graph. All right, remind me, we're gonna do this one afterwards. Remind me to come back to 2017, right? I'm gonna leave this one for last. Let's look at straight calculation ones first. Remind me to come back to 2017, guys. Remind me to come back to 2017 to do that linear reduction. This is a linear reduction question. Right? Comes under the logs topic. So I'll come back to this one afterwards. 2017. Make a note from it, please. I'll come back to 2017. 2017. All right, to do that linear reduction. Let's try to do the straightforward ones first. So this one I have to draw a graph and all that, right? Also want us to do the inequality. So let's go to 2016. We're going to come back to 2017. 2016. 2016, we did this already. And we are searching for source, logs, and indices. Here's a logs question right here. It's an indices question. Let's see what comes up for it. This is a disguised quadratic equation. It's a nice question. There's a lot in it, right? Let's see up here. That's a function. So starting right here. Starting right here. So this is an indices question, which really it becomes a disguised quadratic equation. All right. So we have to basically break out these using indices, and we're searching for a quadratic equation in it. So we have to learn, we have to know that this expression is the same as 2 to the x squared times 2 to the power 1. But I give it that plus 5 times 2 to the x minus 3 equals 0. But understand that agree that this is equal to this? But I
Yes,
agree
sir.
that?
Yes, sir.
But the 2 to the 2x is the same as this. And then the plus 1 means that you're multiplying by a 2 to the 1. So we're reversing the laws of logs. We will consolidate these to that. So this actually becomes 2 times 2 to the x squared plus 5 times 2 to the x minus 3 equals 0. So this becomes a quadratic in x. And what some teachers will do, they will say, put it as 2y squared plus 5y minus 3 equals 0. Some teachers will do that. You actually don't need to do that. You can just work with the 2 to the x as the variable, just the same. Just as how we normally work with the when we're doing the trig ones. Just know that the variable is 2 to the x. It's a quadratic in 2 to the x. So I don't have to do this y business. I don't have to. I'm not gonna do it. Not gonna do it. If you want to do it, if you learn it that way and want to do it that way, no problem. Usually I do have a lot of space anyway to be converting it to y and converting it back. If you feel comfortable putting it as y, then go ahead. I'm gonna factorize this as is. These are prime coefficients. It factorizes easily. All right. 3 and 1. All right. So 3 and 2 is 5. But something wrong here. So let me see. Boom, bang, boom. All right. Let's see. I'm not seeing the factors what I talked about. Let's see. I'm gonna factorize it like this. So factor of this would be 2 times 2 to the x and 2 to the x And then I need factors of the 3 is 3 and 1. Can we put the 2 times 3 give me 6. 6 minus 1 is 5. So I want the greater product to be positive. The far product is positive. This is a plus, this is a minus, equals 0. If you use y, it would be 2y minus 1, y plus 3 equals 0. If you wrote this equation as 2y squared plus 5y minus 3 equals 0. If you use the y, right? But I'm not using the y. Let me take it off. All right. So now I've gotten to the stage where I can say that this part equals 0. So I'm getting that the 2 to the x will be equal to carry over the negative 1, become positive 1, and then divide under 2. So I'm getting a half, or I'm getting 2 to the x equals negative 3 from this one. 2 to x equals negative 3. But I understand those? But I understand those?
Yes,
Yes,
sir.
sir.
Now, this one is not valid. Why is that one not valid? It's not valid because why? Let me hear. A positive number raised to a power cannot be negative. A positive number raised to a power cannot be negative, regardless of what the power is. A positive number raised to a power cannot be negative once that number is real. Positive number raised to a real power, I should say, cannot be negative. I'm assuming that x are real numbers. Cannot be negative. So this is not valid. And you can test it as well, because if you are trying to solve it by taking the log of both sides to get the x from out the power, then you'll be attempting to find the log of a negative number which does not exist. So anyway you want to look at it, this side of it is not valid. A positive number raised to a power cannot be negative. And so you really want to solving this. And this half is really 2 to the minus 1. So the simple thing, we have 2 to the x equals 2 to the minus 1. And so clearly the x is equal to negative 1. X equals negative 1. So this is my answer right here. Are you good with that?
Yes, sir.
All right, good. Next question. This one, they want us to make C the subject. So we get this C from out the power. Right? Want to make C the subject. First thing I'm going to do, I'm going to move this K, divide it under here. And I'm trying to reduce this side. I'm going to move the K, divide the K under here. So I'm going to get T over K equals P to the H over C. P to the H over C. Right? Then now, to get this C from out of the power, I'm going to take the logs of both sides. I'm going to take the log of this side. I'm going to take the log of this side. All right, let me shift this over some. Because I want to get the 1 over C. See this C under here? This C under here is really 1 over C. So I can move the 1 over C if I move the power and put it to the front. I don't have to move the H, you know. I can just move the 1 over C. The C under here is 1 over C. So I can move the 1 over C and bring it to the front. And I can leave the H up there. I'm only interested in moving the C. C, I want to make the subject, so I need to get it out of the power. So then this will become the log of T over K equals 1 over C times the log of P to the H. I'm not moving the H. I don't need to move the H. But I understand that.
Yes, sir.
Then to make the C the subject, I'm going to multiply out the C and divide all of this under here. And the C will become the subject, like so. The C will become equal to the log of P to the power H divided by the log of T over K. Done. That's it. I don't have to do anything. That's it. C is the subject. But understand that?
Yes, sir.
Yes, sir.
And that's not the only way to express it. Because if I want it, I put the h to the front now. Let me shift it over. So I could say equal to, I can put the h to the front and write h log of p over, and then this is the log of a quotient. It becomes the difference of the logs, the log of t minus the log of k. So this is the same as this. So I feel if I left this, it will be still good enough. What about that? And you all saw how I move the c under here, which is really 1 over c. So I moved the 1 over c to the front. I did not need to move the h. All right? And that is it. That is it. All right. So now I'm solving this logs equation. Look away the dog, man. Jeez, you can lock up the dog, please. I'm solving this logs equation. All right. All right. So what I'm going to do, I'm going to move this 4 up here, and I'm going to consolidate these two logs expression. Consolidate them. All right. Using the laws of logs. Remember, the log of a sum become the log of a product. So this side become the log of x plus 1 times x minus 1. And this 2 comes up here to become the power. So it becomes equal to the log of x plus 2 squared. You have to know the laws of logs. These things just become easy when you know the laws of logs from left to right and from right to left. So I brought it down to the log of something, n equals m. That's what I have now. The log of n equals the log of m. So it means that this thing equals this thing. I can drop the logs. The log of something equals the log of another thing, then those two things must be equal. I'm not saying that I'm dividing through by logs. It's just simple logic. If the log of one thing equals the log of another thing, then those two things must be equal. Simple as that. So therefore, this equals that. All right? Those two things that I've underlined are equal. Now, this first part is the difference of 2 squares. So it is equal to x squared minus 1 equals, this thing is a perfect square. I'm going to expand it. It becomes equal to x squared plus 4x plus 4. The x squared terms are eliminated. And if we're trying to make x a subject, I'm going to take this 4, bring it on this 5, and get negative 5. And so my x is going to be negative 5 on 4. Let me if you all see that. X is negative 5 on 4. What are we going to do that?
Yes, sir.
Now, let me tell you something now. I'm not going to leave this as an answer. I'm going to say not valid. I'm going to say this answer is not valid. X equal negative 5 on 4 is not valid. But you can tell me why I'm saying it is not a valid answer. That is the answer, but it's not a valid value for the equation that was given. Why is it not valid? But this is negative 1 1/4, don't it? If I put negative 1 1/4 for the x here and add it to the 1, this thing will work out to find the log of negative 1/4. That part right there. You cannot find the log of negative 1/4. So this answer is not a valid answer for the original equation. Similarly, if I put it here for the x, I will find the log of negative 2 1/4 because it's negative 1 1/4 minus 1. Still not valid there as either. So it is not valid for the given equation. It cannot work in the given equation. But understand that. So it's not really a valid answer, but just the answer that they get from the equation. It's not valid. But any value that will cause you to be finding the log of a negative number is not valid. So this is not a valid answer, not a valid value for x in the equation. So happens, but that is what it is. So they will give you a mark for getting that, you know. But really and truly, it's not a valid answer because it cannot work in here and it cannot work in there. So it cannot work. But I understand that.
Yes,
But I go to that. All right, good. All right. This is the answer I have to present. All right. And that is that. All right. So I think that finishes 2016. Let's go down to 2015 now. 2015. I think we're going to have to start writing on the next side. 2015 paper, there's no space to write on 2015. Jeez, I'm trying to copy that, man. One second, please. All right, guys, sorry about that again. All right, so we're searching for the question on this paper. It's 10 o'clock now already, so we're just gonna finish with the logs and then we'll call it tonight, all right? So we can make up the time tomorrow with the other topics. Maybe what it is, we might have to decide to start keeping out some of the earlier papers. Maybe work all the way down to 2016 or something like that. All right, for the remainder of the session. So we basically want to touch all the topics. So basically, I want to solve these two questions now. These are the logs question on this paper. We might have to come back to the linear reduction tomorrow. All right. So I want to solve that. So this can be brought to base 4. All right. So this one can bring it to base 4. So let's do it here over this side. So the 16 is the same as 4 squared. So I'm going to write it as 4 squared raised to the power x plus 2 equals this quarter. I'm going to write as 4 to the minus 1. Then I can multiply these out and get 4 to the 2x plus 4 equals 4 to the minus 1. And therefore, since the bases are the same, then the powers must be equal. And so we have 2x plus 4 equals minus 1. So the x equals negative 5 over 2. So carry this over here, becomes a negative 5, negative 1, negative 4, negative 1, and negative 5. I will divide under the 2. So that is it. X equals negative 5 over 2. We're solving this guy here now. We do it here. Yeah, we can do it right here. So for this one, again, we're gonna consolidate these two. It's a plus, it becomes the log of the product. So this side becomes the log to base 3 of x plus 2 times x minus 1 equals log to base 3 of 6x minus 8. So log of something equals log of something. So those two somethings must be equal. As simple as that. Right? And so when I expand this side, they are equal. These two things must be equal. This must be equal to that. We're going to write this side, span it out, it will become x squared. And the middle term is a far product and the near product. That's 2x minus x. So the middle term is just x, 2x minus x. All right, so the middle term is x, so it's a plus x. And then the 2 times minus 1 is negative 2. And that is equal to 6x minus 8. Transpose it over into a quadratic equation. Move these over here. I'm going to get x squared minus 5x plus 6 equals 0. But understand that. We're going to do that.
Yes, sir.
We're going to factorize
Yes,
this guy
sir.
here. We're going to get x and 2 and 3. Signs are the same. They are both negative. So the signs in the bracket are both negative equals 0. So I'm getting x equals 2, x equals 3. Because the original equation, all the values can work. That will remain positive, that will remain positive, and this will remain positive. So these two answers are valid answers. That's it. All right, that's that. And there is nothing else down here to do. Search logs and indices. All right, let's go on to 2014. 2014 down here. So maybe what we have to do tomorrow, guys, just make sure that we push through the topics is to just never stop at 2016. So we're from 2016 to 2022, because I really want us to do all the topics, and I find that, you know, it's really taking some time to go through all the papers, right? So maybe we just have to just do 2016 to 2022 from tomorrow, because I want us to finish all the topics. We're looking forward now, 2014, right? 2014 right here. But just face the reality that the time is limited. All right, it would be nice to do all of them, but see that is a challenge because we're on 2 hours already since we started. All right, so this one has none. No search logs and indices in this one. And yeah, nothing in this one. So none on that paper. Let's go to 2013. 2013 right here. 2013. 2013. Right. The next one right here. That's a logs question right there. I think that's the extent of it. Yep. That's that. All right, let's go. So this question gave us this. I must prove that it is equal to that. All right, so in essence, what they're trying to do from this equation is to make x a subject. That's what it's really about. Take this equation, you have to take logs to get the x that we want out of the power. After take logs, we want to get out of the power. And we're going to factorize out and make x a subject. That's what it's all about. When the thing that you want is in the power, you have to take logs to get it out of the power. As simple as that. Remember that and you're good. When the variable that you want to find is in the power, you take logs to get it out of the power. Take logs to get it out of the power. All right? All right, ready now. So I'm given this equation. 5 to the 3x minus 2 equals 7 to the x plus 2. All right, these bases are different, and so I have to go and take logs. I'm not going to use an indices method to do it. I have to use a logs method. The first thing is that we're going to take logs of both sides. Take the log of this side and take the log of this side. Then this whole power comes to the front, and you have to bracket it up as a whole power. You have to bracket it up as a whole power. That's an important thing. Similarly, you have to bracket up this as a whole power and bring it to the front. Right? Bracket it up. Very important. Then it's going to become 3x minus 2 as a whole bracket and the log of 5. Now look at what happens if you don't bracket up. That's what they're going to put. And you might go away thinking that this is a term by itself. It is not. It is this that is the entire power that you took out of the power that you removed. Similarly over here, you have to bracket up the x plus 2 as a whole power times the log of 7. If you don't put the brackets, then you might go away thinking that you're doing the 2 times the log of 7 by itself. So you have to bracket that up. After I bracket it up, remember we're trying to make x a subject, so I have to expand out everything, group terms in x on one side. So expand out this and expand out that. So it's 3x times this first. So it becomes 3x log 5 minus 2 log 5 minus 2 log 5. This side becomes x times the log of 7. So it's x log 7 plus 2 log 7. Remember, we're trying to work towards this, right? So I'm going to group the terms in x on the same side, this and this. Bring them on the same side. I don't want this over here. I'm going to take it over to that side. So I'm going to get, you see this 3? I can move it up back in now because I just want the x alone. I can move it back up, but I can't leave it for the time being and show it. So I'm going to write 3x log 5 minus x log 7, that's what this becomes when it comes over here, is equal to 2 log 7, and this goes over and become a plus 2 log 5. I'm going to factorize the x away from these two terms. I'm going to get x into 3 log 5 minus log 7 equals, based on this answer that I have here, I can factorize away the 2 from these and get 2 bracket, just like they put the log 5 in front. You see, they put the log 5 in front. I'm going to put 2 log 5 plus log 7 over here. And then a matter of dividing this under here now, I need the x as a subject. But in the same breath, this 3 can come up here on the power. And so I can write this as x equals 2 log 5 plus log 7 divided by, I'm going to put the 3 on the power and write log of 5 cubed minus log of 7. Log of 5 cubed is 125. And so it becomes equal to 2 log 5 plus log 7 divided by the log of 125 minus the log of 7. And all I have done is put that in some brackets, which is not really necessary, but that is it. Shown. That was shown. But I go to that.
Yes, sir.
All right. Beautiful. And then we'll jump now to 2012. See what is there, 2012. 2012. 2012 is 2012, where are you? 2012, where are you? 2012. Right here. Pop, 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 pop. We're looking for the surds, logs, indices. And there is under this guy's quadratic equation right here. Oh, well, this is logs and indices as well. It's a linear reduction. So of those two questions, C and D, these two. All right, these two. All right, let's do them over here. So the first one is another this guy's quadratic equation. So I have to break this down. All right. So we have 3 to the 2x. Let's look at it. It's 3 to the 2x minus 9 times 3 to the minus 2x equals 8. Now this 3 to the minus 2x, we don't work with negative powers. But I write as 1 over 3 to the x. It's a reciprocal. So it says 3 to the 2x minus 9 over 3 to the 2x equals 8. Good. And then we're going to expand this out of the denominator by multiplying through by 3 to the 2x. Multiply through by 3 to the 2x. Multiply 3 by 3 to the 2x. This becomes 3 to the 2x squared. 3 to the 2x squared minus 9 equals, this I also multiply by 3 to the 2x becomes 8 times 3 to the 2x. So this is really a quadratic in 3 to the 2x. I'm not going to trouble this 3 to the 2x and 3. It becomes a quadratic in 3 to the 2x. Transpose this over this side. It becomes 3 to the 2x all squared minus 8 times 3 to the 2x minus 9 equals 0. So this 3 to the 2x is my variable. It's a quadratic in 3 to the 2x. Could be written as y squared minus 8y minus 9 equals 0, where the y is 3 to the 2x. All right, that is it. But I'm not going to call it y. I'm just going to work with the 3 to the 2x and factorize it. So this becomes, when I factorize it, becomes bang, 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 bang equals 0. Factors of this is 3 to the 2x and 3 to the 2x. Factors of 9, where the difference is 8, is 1 and 9. Signs in the bracket are different. Give the greater one the negative sign. Far product is greater than near product. So I'm going to make the far product negative and the near product positive. So this one, if I put this one equal to the 0, it becomes 3 to the 2x equals negative 1. Or to put this one equal to 0, I'm getting 3 to the 2x equals 9. Again, this is not valid. Positive number raised to a power cannot be negative. So this one is not valid. Not valid. Positive number raised to a power cannot be negative. So that one is not valid. Over here, this 9 is the same as 3 squared. So this is 3 to the 2x equals 3 squared. We can use our indices method to solve it, because we can bring them to the same base. So it means that 2x equals 2. 2x equals 2, which means that x equals 1. That is the answer. Nice and easy. Gotta go to that?
Yes, sir.
All right. Lovely. Next part says we have to express this in this form. It's formed like a straight line. You know? It is like y equals mx plus c. You know? That's what this form is. All right. So basically, I need to get this sum out of the power. See, they've got the x sum out of the power. So we have x cubed equals 10 to the x minus 3. We want to get this sum out of the power, we have to take the logs of both sides. We take the log of this side and you take the log of this side. Remember, the x minus 3 comes out as a whole. All right? And then this 3 comes to the front as well. So it's going to become 3 log x. 3 log x equals x minus 3 as a whole and the log of 10. The log of 10 is equal to 1. Remember, log to base 10, this log of 10 is equal to 1. This thing is equal to 1. And so we're left with this. we're left with 3 log of x equals x minus 3. But they want the log of x to be the subject. To make log of x the subject, we need to divide through by this 3. Divide by 3, divide by 3. So to divide by 3 or multiply 3 by a third, then we get the log of x equals a third x minus 1. And so it is in the same format. Okay? In the same format as that they gave us. Log x equals ax plus b. Just like the plus b is minus 1, and the a is a third. And the LG is the same as log to base 10. Same as log to base 10. That's why I write for the LG. All right? It says, hence, state the value of the gradient of the graph of log x versus x. Because now, what does that mean? Is that this now is in the form of the equation of a line, which is y equals mx plus c. So this is your y, this is your x, this is your m, this is your c. So if you plot log x against x, then m, which is a third, is going to be a gradient. That's what they're saying. So log x versus x is going to give us a straight line. Give us a straight line with a gradient of m equals a third. And if they ask for the y-axis intercept or the log x-axis intercept, it will be the c equals -1 if they wanted this. But this time, this is the answer. Third. The answer right here is a third. The gradient is a third. That is it. All right. At this time, is it now? No. Okay. I'm going to stop it there. Remember that we did in 2017, linear reduction. So we have that to do. I think going forward, just to ensure that we cover the topics, I'm just going to work from 2016 to 2022. 2016, 2017, 2018, 2019, 2021, 2022 on the specimen paper. That's 7 papers we'll be doing. I'm going to work from 2016 to 2022 on the specimen paper from tomorrow. Okay, guys? So we can see we can push through the topics a little bit faster so we can actually complete them. I know that I did not do the linear reduction question on 2017, so we have that to do. We also did not do the inequalities. So we still have those to do. All right, so let us push tomorrow. Maybe we need to have 2 sessions again tomorrow. Tomorrow is Sunday. So we might have 2 sessions again tomorrow to see if we can cover a good number of topics. We still have differentiation, we still have integration, we still have statistics and probability. And we have kinematics. Just like the kinematics, we don't have to do much of the kinematics from the old days, because the kinematics and the new syllabus since 2021 is sort of simplified in differentiation and integration. Right? So don't have to do those old-time kinematics questions. Right, so let us pick it up back tomorrow now. It's the same time tomorrow. Tomorrow Sunday. It's 12 midday in Trinidad, 11 a.m. in Jamaica. And we'll have a session up to 5 o'clock. We'll have a 5-hour session, break for 3 hours, and then do a session again in the night. But we can decide on that tomorrow. Let's get through as many topics as we can get through tomorrow. I really want us to touch every single topic. All right, but based on how fast we're going, or based on the pace that we're going, I think it is prudent for us to just do 2016 to 2022. But I agree with that.
Yes, sir.
So it's better we cut the volume and get in more topics rather than go for the volume and get in less topics. So let's go for more topics. All right, if we finish all the topics in time, then we can jump back and do the 2015 or the 2012 and the remaining topics. If there are any particular question on those papers that I feel that I want you to see, then I'll pick those questions out just the same and do them. All right, but let us focus on 2016 to 2022. All right, so see you tomorrow, guys. Have a good night. It's finished. So what are gone? They're gone. They're gone. They're gone already.
You saw the one there?
Yeah.
Or you just let it talk with you?
I don't know what they do. Just them jumping out.
Let me tell you now.
Yeah.